Welcome students. This is your first lecture in the plus one class, and in this lecture we will study about physics. But before starting physics, we have to discuss some mathematical rules that is used in our physics class. Firstly, we will discuss about the differentiation, and after that one we will discuss about the integration. Okay. So without wasting any time, you are starting about the differentiation. Okay, our first topic is about differentiation, and it comes in the category of mathematical tools that were used in the physics. Differentiation differentiation it is simply defined as it is defined as the rate of change of a quantity with respect to with respect to another quantity. Okay, it is simply defined as the rate of change of a quantity with respect to another quantity. Mean to say that we have two quantities, and one is increasing, or either it is increasing or decreasing, and we have to check it with the check it with respect to the another quantity. Suppose we are checking the change in y-axis with respect to x-axis, then we will write it as differentiation in the form of differentiation, and it will be equals to dy by dx. Here dy represents the change in y, dx for dx with respect to with respect to change in x. Okay, it is with respect to x, not change in x. Okay, here dy by dx means change in y with respect to x. Okay, again, if you are writing that dz by dy, it will again means that change in z with respect to change in y. Here dx and dy represents the small change in x and small change in y quantity. Or suppose we have a term like x raised to power n. Suppose we have a term x raised to power n, and we have to differentiate it with respect to y. Okay, if we have to differentiate it with respect to y, and here it is given that x is not a constant quantity, x is a variable, then the differentiation of x raised to power n with respect to y will be equals to m comes forward, and we will reduce power by 1. X raised to power n will be equals to n x raised to power n minus 1, and again we write dx by dy. Okay, dx by dy. So the formula for the differentiation of x raised to power n with respect to y, when x raised to power n is not a constant quantity, is equals to n x raised to power n minus 1 dx by dy. Okay, suppose now you are discussing that here the change is along x, then x raised to power 7. We have to differentiate x raised to power 7 with respect to x only. Okay, here both are the same quantities. Here the different, we are checking the change in x with respect to y, but we have in this term we are checking the differentiation, or simply checking the change in x raised to power 7 with respect to x only. Then the answer will be differentiation of x raised to power 7 with respect to x. According to our formula, power comes forward, so 7 comes forward, 7 x raised to power, and we will reduce the power by 1. So 7 minus 1 is will be equals to 6, and again dx divided by dx, or from there we can simply can cut it also, or we can again write it as the differentiation of x is equals to 1. Okay, so the differentiation of x raised to power 7 is equals to 7 x raised to power 6. Let's discuss about more examples. Suppose we have a polynomial. We have a polynomial given in the form of y cube plus 7y square plus 3y plus 2, and we have to differentiate this polynomial with respect to y. Okay, then we have to just use this formula. Okay, x raised to power n, differentiation of x raised to power n is equals to n x raised to power n minus 1, and the differentiation along the respective term. So firstly we will apply differentiation on each term. Differentiation dy by dy of y cube plus 7 comes forward, means we can take it outside because 7 is constant. Then dy by dy of y square plus 3 can be taken out, and differentiation of y plus differentiation of 2, differentiation of 2. So again applying the same formula, 3 comes forward and power is reduced by 1, so it will be equals to 3y square, 3 minus 1 is equals to 2, plus 7, again using the same formula, 2 comes forward and y power is reduced by 1, 2 minus 1 is equals to 1, and we have no need to write 1. Next one is plus 3, again y, here the power is 1, 1 is multiplied by 3 is equals to 3, and power is reduced by 1, y power 1 minus 1, and we know that 1 minus 1 is 0. Okay, so we have here y raised to power 0. Okay, so you can write y raised to power 0 plus differentiation of 2. Here 2 is a constant. Okay, and we know very well that constant quantities do not vary, or we can simply say they do not change with respect to any quantity. Okay, so the differentiation of any constant quantity will be always equals to 0. So the differentiation of 2 will be 0. Okay, it will be 0. So we have the answer 3y square plus 14y plus 3 into y raised to power 0. Any quantity having power 0 will always be equals to 1. Okay, so y raised to power 0 will be equals to 1. So 1 multiplied by 3 is equals to 3. So the differentiation of this polynomial will be equals to 3y square plus 14y plus 3. Okay, now let's discuss about the differentiation of some trigonometric terms. So today we will discuss about sine and cosine function only. Okay, and after that we will discuss about the multiplication rule. Firstly, differentiation of d by dx of sine of x. Okay, sine of x, differentiation of sine of x, it will be equals to cos of x, cos of x, and similarly differentiation of dy dx of sine cos of x, differentiation of cos of x will be equals to minus sine x. Okay, we will discuss only two terms here, sine and cosine term. After that we have to discuss the differentiation of two multiplicative terms. Suppose one is algebraic term and next one is our trigonometric terms, and they were multiplied with each other, and we have to find out the expression for that terms. Okay, suppose we have to find out the differentiation of x square sine x. Here the term is given d by dx and we have to find it. Okay, so if we have problems like this, then we have to use a standard formula. Suppose d by dx, I am representing x by x square by u and sine by v, and we have two terms u and v which were multiplied with each other, and we have to find out the differentiation. Then the differentiation of uv will be equals to differentiation of u, v remains as it is, plus u remains as it is, differentiation of v. Okay, differentiation of v. So we use this formula in the above problem, then it will be equals to d by dx of x square sin x will be equals to differentiation of d by dx of x square, because in place of u we have x and in place of v we have sine. So here sine remains as it is, because in the first term differentiation we have to differentiate u and v remains same. So here sine of x remains the same, plus again u remains the same. Now u remains the same means x square remains the same. Okay, so we write x square as it is, and d by dx of v means differentiation of sin x. Okay, now we will apply the formulas that we have studied in the above case. Okay, so the differentiation of x square, again power comes forward 2 and power is reduced by 1, x remains same. So x square, differentiation of x square will be 2x raised to power 1, 2 minus 1 1, and sine of x as it is, plus x square as it is, and the differentiation of sine x, we already written that differentiation of sine x is equals to cos x, so it is cos of x. So the differentiation of x square sine x will be equals to 2 sine x, 2x sine x plus x square cos of x. Okay, this is the simplest differentiation that we have discussed today, and in the next lecture we will discuss about the differentiation of some more complicated terms. We have to also discuss about the logarithmic functions and exponential functions, that will be done in the our next lecture. So guys, till then, take care. Thank you.